Hello, ladies and gentlemen. Thanks for joining us. Welcome to the fourth Positive Thinking, the Thinking Highways webcast, not webinar, but we'll come to that. So thanks for coming. Thanks for taking time out of your day. For those of you in California, it's still morning. For me in the UK, it's dinner time, but I'll try and talk quickly. Now, I am surrounded, although virtually, by a veritable expert panel of connected vehicles leading lights. So I'm going to introduce them to you. First of all, we have our regular panelist from Zero Cash, Bob McQueen. Hi, Bob.
Oh, hi there. So I'm a leading light in a vehicle. Does that make me a headlight?
Yes. Okay, that's our new,
Okay.
that's our new saying for you. So Bob is the headlight of the industry. We also, now I don't want to embarrass Richard, but in front of him, I've introduced him as the world's leading authority on automated vehicles and connected vehicles, and he doesn't like it. I'm going to say it again in front of all you people. So please welcome Richard Bishop.
Hello.
Which I think that's true, Richard. I'm not going to blow your trumpet for you, but most people wouldn't dispute that. So please welcome Richard. Also, we have from the Car Connectivity Consortium in Palo Alto, California, Alfred Tom. Hi, Alfred.
Hello. Thanks for having me.
Okay, good. Thanks for joining us. Alfred's got a slight, about a half-second delay, so I will try and we'll cover that hopefully. But this is the problem with being 8,000 miles apart from each other. We also have.
He was in his connected vehicle.
Well, he should be. We should all do it from a car. Someone should be doing this from a car. I think you're right. Next time we'll do it from a car.
Hey, Kev,
So,
I'm doing this from my car, so I qualify.
oh, you are? Oh, brilliant. Excellent.
Oh, wow.
Richard really is doing it from his car. Good.
I'm stealing somebody's internet connection.
Ah, perfect. We really are doing a connected vehicles conference from a car. This is perfect.
Right.
Who else would do this? Great. Thank you. We've also got from Stanford University a leading expert on autonomous vehicle and connected vehicle legal issues. That's Bryant Walker-Smith. Hi, Bryant.
Hi, Kevin. We really need a laugh track for this, I think.
I think we should. Yeah, it is. I did comedy for 10 years, and I'm quite used to telling jokes and people not finding it funny, or not laughing at all, but it's people nodding at you, and that's not what you want. And also, finally, last but by no means least, we have the former director of the ITS-JPO. We have Shelley Rowe. Hi, Shelley.
Yes. Hey, great to be here.
Well, thank you. We do get to the serious bit in a minute. It isn't all just laughs and jokes from Bob. Anyway, so what's going to happen now? That the panelists will be giving their presentations, and then after about half an hour, it's you, the audience. You take over. You ask the questions. You send questions in, and then for half an hour or so, Gareth will read out your questions, and hopefully that's where the debate starts coming. You can ask questions to particular speakers or to everyone, and then we'll point out who should answer the question. There's 2 points I want to make, though. Lots of questions we had last time were, will I get the slides? Yes. Every attendee will get a copy of the slides if the speakers will allow you to have the slides. That's not always the case, but we've cleared that, so hopefully everyone will be able to get the slides. Also, this is being recorded. Hopefully my bit's being edited out, but this is being recorded, and that will be made available shortly after this webcast, probably sometime after Easter, if you celebrate Easter. So enough for me. I'm going to hand over now to your driver for the day, Mr. Bob McQueen. Hi, Bob. Go for it.
Oh, hi. What a concept. The driver of an autonomous vehicle. Welcome, everybody. I should also add that although we have 10 talking points, we are not guaranteeing that we will cover all 10 points. These were talking points to give the panelists some guidance, and if we don't cover your favorite point, then just send an email to Kevin and complain to him. How's that, Kevin? I've given you a role.
Yes, no, that will... yeah, no, I'll file them all together. I've had 5 of those now. So,
and will the
email folder?
Will the slides also be on the H3B Media website?
Oh, don't ask that. You know the answer to that question. Yes, in time, yes, they will be. Thank you, Bob.
All right, cool.
Can we move
Good
on?
stuff.
Thank you.
Yes, I think we're starting with Shelley first. Is that correct?
That's right. Yep.
Good job. So, Shelley, without further ado, I'm just going to hand over to you, and you can go for it.
Okay, thanks, Bob. And it's a real pleasure to be part of this very impressive panel today. So I'm just going to hit a few high points, and you can go to the next slide. Thank you. One of the things that I am very excited about is all of the activity that's going on in the connected vehicle space. There are just a few little factoids up there, and some of my colleagues can speak more fluently about these issues. But there is so much going on, and I think it is an important point, and you can go into the next slide, to understand when we say the words connected vehicle, what it is that we actually mean. it seems like it's a very important distinction to me to understand, because they're fundamentally different technologies that are being talked about, and we lump them into one term, connected vehicles. And I believe that the trajectory on the different technologies is likely to be very different, and we're seeing so much going on in the cellular space right now. And in fact, the reason I make that distinction is because I'm going to focus my remarks on the DSRC version of connected vehicle. But I preface that by saying that I really do think that there are different things going on depending on how a vehicle is connected, and I think DSRC is just a piece of the bigger puzzle. So next slide, please. And I'm not going to dwell on some of these things. And the slide people, this is anime. There you go. Thank you. There's one more. I'm not going to dwell a lot on this because I want to get into some of the later slides. But I do think in the DSRC world, it is important to just revisit that we are expecting a decision from NHTSA later this year about the future of the technology for vehicle-to-vehicle connectivity, and then next year, the following year, for heavy vehicles. So that is an important milestone. I do think it has some implications for the industry, but I think it's, again, a very different picture for this than other kinds of connected vehicles. There's also research underway for vehicle-to-infrastructure, specifically traffic signal kinds of connections, and of course there's some studies going on there looking at some infrastructure issues. And next slide, please. And I've actually not chosen to focus much on the safety pilot. That's been briefed so much, but I did want to mention it, that it's going on right now in Ann Arbor. The last that I heard from them, they're not able to share data and those sorts of things, and so there's not a ton of information coming out of Ann Arbor these days, except to say that they're on schedule, the vehicles are deployed in the field, they've got the infrastructure in, as I understand it, and they are collecting data and sending it to Volpe, who started the analysis for NHTSA on NHTSA's behalf. But that's about all that we really know about what's going on in Ann Arbor, but that's feeding data into that decision-making process for NHTSA. Next slide, please. So having said that, what I thought I was best to spend my time on was to identify the issues that I think are important for us as an industry to pay attention to, that are in the USDOT realm. And again, I just feel like I have to continue to emphasize that is so not the whole universe of the connected vehicle stuff. In fact, I think it's a small piece of it. But these are the issues that I think are important to watch that are going to be coming out of USDOT. Clearly, the NHTSA agency decision later this year, fall or winter of this year, about the role of the vehicle-to-vehicle technology and possible future regulatory action. Now, I want to go a little deeper than that, and I'm going to elaborate on these other 2 points. I think specifically there are some things that we need to pay attention to around that decision. One is what the security network looks like, who's responsible for it, what the design looks like, how they articulate that, and the basic safety message. And I'm going to come back to both of those. The other thing that I think is important to watch right now is the 5.9 gigahertz issue. The spectrum has a lot of debate going on around it right now about sharing that spectrum. There's a lot of concern in the industry about whether that's a little too early to determine if it's ready to be shared. How do you make precautions to make sure that the safety applications are protected and not interfered with? That's an active issue right now. If you're not currently following it, I would highly encourage you to pay attention to that. It clearly is a game changer for this particular type of the technology. The other thing I think is worthwhile to watch and pay attention to, although this is later, is whatever FHWA might say about infrastructure for vehicle-to-infrastructure types of applications. The thing that I want to emphasize, though, about this, that I find that there continues to be such confusion on, the federal government has no authority to require any infrastructure to be put in by state or local governments. So the model that's being looked at, and I feel very certain this is still the case, and perhaps my colleague from GM can even speak to it, is looking at security network options that don't require infrastructure to be installed by state and local governments. So let's move on to the next slide, please. and I'm not going to go into this at great detail, but I do think it's important to recognize that the security system behind the V2V DSRC program is really a key piece of it, and it's very complicated, and it's a big question about how it would work. And a lot of the research that's being looked at and looked at by CAMP was examining the viability of doing some vehicle-based security systems, and so you didn't have the reliance on infrastructure no matter who owns the infrastructure. Now, to elaborate on that, though, the next slide, please, we do need to keep in mind that whatever the security system looks like, if we do have any kind of infrastructure that wants to interact on DSRC for safety applications with the vehicle, it would have to be part of that security system and that trusted network and play by the rules and behave along as like all the other devices on that kind of network would have to cooperate. So that's an important thing to keep in mind for agencies who might want to choose, not be required to, but choose to implement some vehicle-to-infrastructure applications that interact with vehicles. And so let's go to the next slide. And one of the points about that I think we need to keep in mind on vehicle-to-infrastructure kinds of applications through DSRC interacting with the vehicle is that it does require buy-in, cooperation, and work by the automotive industry. So just because we choose to put traffic signals, SPAT messages on signals doesn't do anything unless there's somebody on the other end to pick it up. Now the good news is that there was a lot of work done in this area some time ago with the automotive industry through CAMP. And so what I understand, and again perhaps my GM colleague can speak to this better than I can, that it would probably be a pretty relatively quick application that could be incorporated. AASHTO is currently doing an infrastructure study right now to look at what would be viable options for an infrastructure applications and how might that come into being. Where does it make sense if you're a state or local government? What sorts of places could you justify the expenditure? And again, these are optional installations. There's nothing required here. It would be totally by the choice of a state or local government to install any kind of DSRC infrastructure. Next slide, please. The other thing that I think is very important to watch in the NHTSA agency decision, should they proceed with starting down a regulatory path, is to look at what the content is the basic safety message. And that is the message that would be part of what's distributed through DSRC. There's the basic safety message part 1 that's distributed 10 times per second, basic safety message part 2 that's distributed when an event happens. So the data elements that are in each one of those, part 1 and part 2, and what constitutes an event and the frequency then that's distributed will be key to understanding what other kinds of applications can be enabled by this particular kind of data. And again, this is really just the DSRC part of this equation. It's, I believe, an entirely completely different discussion when you look at other kinds of connectivity. And then my last slide just basically says that, you know, I feel like that we're looking at a dynamic and interesting convergence of a lot of different technologies. Clearly there's technology on the market today. It's growing so rapidly. The connected vehicle piece of the industry is just exploding in so many different ways, and DSRC, I hope, will be a part of it. And then looking forward into the automated vehicle realm, and I know some of our other colleagues today are involved in that area. So those are just some introductory remarks, and I look forward to discussion later. Thanks.
Great, thanks very much, Shelley. Interesting points there. It would be interesting to see much more communication between vehicles. I read an article a few years ago, I wish I could remember the source, where some Japanese researchers have been figuring out that you only have 5 ways to communicate when you're inside a vehicle: hand signals, horn, turn signals, headlights, and hazard warning lights. And that gives you the same communication ability as an insect, which I guess could explain a lot of driver behavior. In fact, I asked the driver on the way home when I overtook him, he was hand signaling to me that I was number 1 in his opinion. Very good. And Yeah, it'll be interesting to see how things pan out. I think Alfred is up next. Is that right? I have the other.
That's right. Yes.
So, Alfred, over to you about the Car Connectivity Consortium and MirrorLink in the connected car.
Sure, thank you very much. Essentially what I'd like to do is sort of give a background of the Car Connectivity Consortium. And what this consortium does is it focuses on the non-DSRC aspect of car connectivity. But it's also perhaps an indication of how the industry can work together on DSRC, because at least thus far in the 2 years of the consortium, the automotive manufacturers as well as the handset manufacturers have actually been getting along pretty well. So next slide, please. So the Car Connectivity Consortium is a global consortium to develop smartphone-based connected car solutions. So it's a standard consortium. Anybody can join. It's not owned by a single corporation. And anybody can implement solutions. And then people who join have access to specifications, certification programs, and other benefits of members. But the basic goal of the consortium is to bring two industries together, and that's the car industry and also the phone industry. Of course, when you talk about the car industry, you have to talk about the tier ones as well, which we call in the industry head units, or the radios. As I said before, it was established a little over 2 years ago, and we actually are over 100 members and authorized test labs. And this is the key point, and this is what people kind of overlook sometimes, is that we actually represent a very, very large percentage of market share in both the automotive and smartphone industries. And that's very important when you want to get standards and technologies adopted by a wide swath of the industry. So MirrorLink is the technology we're developing first, and it's technology that's governed by the CCC. And the next slide, I think, has a little indication of what MirrorLink is. Well, actually, next slide is probably the badge slide. So, so this is indication of all the. Actually, can you go just one before? Yep, there we go. So as you can see, we have a very large membership. Very good representation from the OEM auto industry, the OEM handset industry, and also various tier 1 and tier 2 automotive suppliers as well. Next slide. So what is MirrorLink? So MirrorLink is essentially a way to manipulate and access the services on your phone without looking at or touching your phone. So all cars have controls and UI elements that are deemed to be appropriate to use in the car environment. The smartphone is not deemed to be appropriately used during the car environment. So what we want to do is essentially use the car as sort of like a peripheral to the phone that controls the phone in some manner. So that's essentially what MirrorLink does. Now, the way it does it is it uses a screen projection technology to project whatever's on the smartphone screen to the screen in the center stack of the vehicle. And then you use vehicle controls to manipulate what's happening on the screen. The big difference is that you can't project anything you want onto the car screen. And so there is a pretty in-depth application, certification, and testing program that ensures that only apps that have been tested for safety can be used in certain conditions when you're in the car. So that's essentially what MirrorLink is. And as far as the connected car goes and traffic safety and things like that, a lot of these phones have LTE built into them. So you can get the phone as a way to enable connected vehicle apps in the car. Next slide. So what we're working on next within the consortium is applications. And obviously we can sit there and build this, great DSRC networks, regulations, and whatnot, but what's going to matter if there are no applications for it? So when you talk about cars, you talk about removing distraction. So obviously we want fewer distracted drivers on the road, and if we don't give them something like MirrorLink, consumers are, as it's proven, going to be circumventing any kind of regulation that we may impose on them. So what's better is to actually give them a technology that they can get access to all their apps and services, but do so in a way that's appropriate. So it's an interesting catch-22 in a way. We want to give them something that's appropriate, yet at the same time we don't want to distract them either. The consortium is walking a fine line between those two differing goals. So what we've done, our response, is that we've developed, for the first time in the industry essentially, a global agreement on application development guidelines. And what that does is it takes the various standards that have been developed in US, Japan, and Europe for driver workload and boiled them down into hopefully easy to understand guidelines for app developers when they develop apps for the car. And we've also developed a certification process that developers can use to upload their apps, get them tested, and then get them certified so that the phones and the cars will actually allow those applications to run. So as far as timeline goes, we are targeting end of first half of 2013, beginning of second half 2013 for a full implementation of this service. Next slide. Right, so that's essentially it in a nutshell. There's more information on mirrorlink.com. If you have questions, you can send them to questions@carconnectivity.org, and you can also contact me at alfred.tom@carconnectivity.org. I help run the ecosystem work group in the consortium, so any question you may have, you can send it my way, and if I can't answer it, I'm sure I can find somebody else that can.
Wonderful. Thank you very much,
That's it. Thank you very
Alfred.
much.
Thank you. I guess we're still pondering the question about whether it's going to be dedicated short-range communications or some form of cellular, whether we're going to put our money on the 15-year life cycle vehicle or the 15-month life cycle smartphone. Anyway, moving on, I think we have Richard Bishop next from Bishop Consulting, and he's going to talk about vehicle connectivity. Over to you, Richard.
Okay, thank you, Bob. Go ahead to the next slide. I've got, I don't know, 3 or 4 slides. This is sort of the big picture. The connected vehicle space is very large and growing. The term connected vehicle is in some ways becoming less and less useful because it covers so much space and so many things are nested within it. But you see this list, a lot of these can be handled through cellular communications such as traffic information. Eco-driving depends on information from traffic signals, so that's more of a DSRC sort of thing. Energy management, very important. The further you can extend the information horizon for a car, the more you can do for something like an electric or a hybrid vehicle, which is constantly managing energy. Just the question of whether to turn on the air conditioning or not by a few seconds could make a difference depending on when the light's changing, things of that sort. So that's a big area. Insurance is really a thriving area. It doesn't get talked about too much in the ITS world. Currently, particularly in the U.S., I'm less familiar with the European market, but there's the pay-as-you-drive systems that use basic vehicle data from what's called the OBD2 port, such as your speed and basics like that. Your location, braking, etc., and just miles traveled. You can use that information to assess risk factors, exposure factors, and the insurers are using that to discount insurance premiums and try to attract some of the better customers out there. That's using a very bare bones data, and the whole industry is moving to a pay-how-you-drive activity where there's sort of the full access to the vehicle CAN bus. There's cooperation between the car companies and the insurers to find a way to share that data and really play out what's the risk profile for a particular driver, and how do you adapt insurance premiums to that, or how do you educate the customer. So that's a big one. That all happens over the cellular system. Next slide. Shelley has covered the DSRC a little bit. You know, regardless of what's happening in all those other areas, DSRC is still critical for safety. There's situations where radar and the other sensors cannot see hazards, particularly intersections, but also where, for instance, there's a large vehicle in front of me and the next vehicle up hits the brakes suddenly. I can be made aware of that through DSRC, but my radar would never see it. Or rather, my vehicle can be made aware of it and then choose to warn me or not warn me, depending on the situation. V2V certainly has the momentum because of NHTSA's ability to regulate it in the U.S. And V2I will come after that. My own sense is that Federal Highways and others on the infrastructure side are waiting until the NHTSA decision happens to, you know, really jump in big time with programs that would enable V2I. So on a geographic basis, just to touch on that a little bit, in the U.S., everything I'm hearing is that NHTSA is very much committed to a decision by the end of 2013, even given the wrinkle that FCC has thrown into things, but that decision timing is on track. There is some consideration, as Shelley mentioned, of reallocating some of the 75 megahertz that are allocated to DSRC right now. A lot of talk about that. I think the general feeling is that this is going to be worked out somehow. We might lose one or two channels to the competing service, which is a Wi-Fi play, but my gut is that this is going to be worked out. It'll take at least a year, I think, if not more. So it could slow down the actual regulatory process, at least under one scenario. In terms of the car companies, in the big picture, they seem to be supportive of going ahead with this regulation. There's no naysayers out there in a big way. That's not to say that once it goes into a rulemaking process, there could be some specifics to the rulemaking that cause pushback by the car companies. So that all remains to be seen. In Europe, the contrast is really interesting because the government is not involved at all in terms of trying to make a deployment happen in the V2V level. The European Commission has certainly supported research, so there's been that sort of involvement. But beyond that, it's been completely market-driven. The player there is the Car-to-Car Communications Consortium, and they last fall issued statements, a memorandum of agreement across their members, which is about, I think, 10 different car makers, for initial introduction of DSRC-based V2V communication starting in 2015. That doesn't mean every car they sell will be equipped this way in 2015, but it means the start of things. And that's really remarkable. In the U.S., the whole focus is on safety. The focus in Europe is safety plus other services, and the determination has been made that there's a favorable business case there. In Japan, it's quite different, different spectrum allocation issues there, and there's two competing approaches. Some car makers prefer one or the other. There's 5.8 gigahertz, which is the electronic toll collection band that can be adapted to exchange data. That's already been done with some deployment. However, others are pushing a different sort of service at 760 megahertz. Those signals would travel much farther. It would be a different system design, but both have their advantages. Okay, next, please. And just, I wanted to briefly talk about automation and connectivity. A lot of my business now is about vehicle automation. Clearly, that area has a very, very strong momentum right now. Thanks to Google as a catalyst, plus some other factors, this topic has become competitively relevant for car companies. That's what's different. The automation idea has been in play since the early 90s, and it was as a research investigation. Now it's competitively relevant. It's got legs. Products are rolling out, and they're going to keep rolling out. The picture you see here is of BMW's prototype that I had the opportunity to ride in on the Autobahn. Very, very solid performance. It actually can change lanes. So, you set your speed. If the traffic ahead of you is slower, it just finds a gap, changes lanes, and continues on. It's really quite amazing. So in terms of this discussion on connected vehicles, the point I want to make is that automated systems have no dependence on connectivity. They can be built and be sold based purely on onboard sensors. So the V2X world is its own parallel path, and so they'll proceed independently for a while. What we'll see, though, is that eventually they will merge, because there's valuable information in the V2X information, and once that information is out there, then automated cars will pull it in just like any other source of information and make the most of it. Okay, I think just one more slide. It's my contact information, and I wanted to emphasize on the automation side, I'm part of the planning team for the Driverless Car Summit. This is the second year we've done this, June 11th and 12th in Detroit, and you can go to auvsi.org to get full details. That's it, Bob.
Thanks a lot, Richard. That was great. I think I've figured out how the connected vehicle works. There's a great big hole in the roof so you can shout at other drivers. Is that how it works?
That's where you put your antenna up.
Moving right along.
Bob, can I just jump in there, just very briefly? Sorry, can I just?
Of course.
Richard mentioned that about autonomous vehicle insurance. There's actually an article in the April issue of Thinking Highways North America, which goes to press on Tuesday, written by a guy called Guy Fraker, talking about exactly that, autonomous vehicle insurance, and the twos and fro's and the against and fors. And it's a very interesting article, quite a long one, quite involved, but the guy's an expert in the legal stuff and the autonomous stuff. So that is going to be an interesting piece. So nicely segued, Richard. Thank you.
Wonderful. Well, the burning question for me is, if my driverless car goes to the grocery store to pick up groceries and has an accident, then whose fault is it? But we can answer that later, I guess.
That's the grocery store's fault.
Yep, it's the grocery store's fault, yeah. I think the car's at fault.
Blame Starbucks, they can afford it.
Okay, next up, Bryant Walker-Smith from the Center for Internet and Society, Center for Automotive Research at Stanford University. Over to you, Bryant.
Oh, thank you so much. I won't actually answer your question about who's responsible. You'll have to wait for the automated presentation on that. The sneak preview is pretty much everybody.
Right.
I want to pull from the last few talks because they were excellent. First of all, to piggyback on Richard's promotion of the AUVSI Driverless Car Summit in June, I want to mention the Transportation Research Board's Vehicle Automation Workshop, July 16th to 19th in California. VehicleAutomation.org has more information. I come primarily from a legal perspective, although I also have an engineering background. And I think understanding the underlying technologies is crucial to understanding the legal and policy issues. So I will talk through a few brief points. The first is I really appreciate Shelley's and Richard's point about the different kinds of connectivity and the breadth of the term. When I think about connected vehicles, I take a slightly more limited definition, which is that I look for some kind of common infrastructure, whether that's physical infrastructure or digital infrastructure, to promote sharing of information. When we talk about a broader conception of connectivity, well, then we're getting into vehicles like Tesla's, which last year had the first over-the-air software update of important vehicle software. And that's an example of starting to connect really to the cloud or to a company's servers, and you can imagine the implications that has for security, for liability, even for regulation of vehicles. The connectivity also just can be distinguished from automation at this point, in that a lot of the applications we're discussing for connectivity still involve some human intermediary. So in the receipt of information, whether cellular or DSRC, a human is receiving information and acting on it. And that, to some extent, limits some of the initial legal issues while still complicating the analysis. So for the first question that connectivity really raises is the driver's duties. Does the availability of this information either enhance or diminish the driver's duties, obligations, with respect to vigilance, with respect to ability? The second is much more on the product liability side. Does the provision of these data or the ability to provide them increase the liability of manufacturers, navigation providers, service providers in any bit? What essentially is the reliance that's being created? The third big area is data protection, and access, and security. We talk about ownership quite a lot, but that's a pretty vague term from a legal perspective. Really, that refers to rights and restrictions on the access or the use of the data. Related to that is intellectual property. You think in the last few years of the cell phone wars that we've seen among various manufacturers and software developers. You could imagine a repeat of that as we really get a better sense for what the underlying technologies are and what their commercial prospects are. Related to some of the discussion from both Shelley and Richard are finally the jurisdictional responsibilities. And that's true certainly with respect to the physical infrastructure. As was mentioned in the U.S., the Federal Highway Administration doesn't have direct authority to order states or municipalities to integrate particular infrastructure. However, I think it's important to mention that FHWA does have pretty strong soft influence on a lot of the decisions. They're in the room for these discussions. The 5.9 gigahertz issue was already mentioned. I would just mention as well that when we talk about sharing that spectrum or sharing any of the spectrums under discussion internationally, well, cars don't move across borders all that much, but other goods that may make use of the spectrum do. So there's some sensitivity there. So those are the big legal and policy issues that I think are particularly relevant to connectivity as opposed to automation, and I'd be delighted to talk about them more in the Q&A.
Wonderful. Thanks very much, Brian. Interesting points raised there. So, Kevin, any questions from the audience out there?
Well, there are. Gareth has those, but I have one. Is it all right if I ask a question?
Oh, I don't
now,
know.
This is well. It depends what the question is. This is for anybody, really.
Only if you say the word webinar.
I'm not sure I want to do that. Okay, webinar. Oh, that's horrible. Right, I feel dirty now. Anyway, so my question is, looking at everyone's presentations, there's lots of dates mentioned. Shelley's mentioned 2017. Richard said 2015. In Europe, there's 2013 mentioned. The question I had actually a guy called Bill Oliver, who can't be with us today, who was also sent a similar question. It's over what time period is this technology that's going to achieve all these exciting automotive goals? When is it going to become widespread? I mean, you're looking at it could filter through, we get a little drip feed of things over the next few years, but actual widespread, like the internet is widespread, the smartphones is widespread. When is this going to become a thing that everybody does and everybody has?
I'll jump in on that. Richard here. Interested to hear what others say too. Well, of course, in the U.S., if we do have a mandate, my basic estimate is that would become effective somewhere around the model year 18 cars, because there's a rulemaking process. There's usually a phase-in period of like 3 years.
Yeah.
So just assume model year 18, and then the rule of thumb over here is that it's about a 5% replacement rate. 5% of the fleet gets replaced by new cars every year. So then you're talking 20 years for every car, almost every car to have it at least. Something US DOT has explored has been the idea of aftermarket devices which could be installed on existing cars. They haven't developed that idea very much, even though it's part of the test in Ann Arbor, and there's a lot of doubts as to whether that would have any commercial viability. I personally kind of doubt it, and I haven't found anybody who really thinks it does. So I'm open to other opinions on that. In Europe, it'll be a pretty gradual process, I think, but I'll leave it at that.
Okay, Shelley, what do you have any opinions on that one?
Yeah, I'll jump in as well. The question, I'd like to start back at the question because I want to link it to one of Richard's first points in his remarks, and that I think that this is where it behooves us to be clear on what kind of connected vehicle technology we're talking about. So Richard's answer, which I completely agree with, is referencing DSRC specifically. I think the answer is exceptionally different when you're talking about the cellular applications that we're seeing right now of MirrorLink. That's happening now. So that's where I think using this wording of connected vehicles, as Richard said, I just find it's causing more harm than good at this point.
Yeah, no, I think you're right, because I invited people to come to and attend this webcast, and people wanted to know exactly what connected vehicles kind of thing they were talking about, because it was such a wide thing. Some people who said, oh, yeah, if it's automated vehicles, I might come, and then other people were interested in the literally cars connecting rather than being connected to each other. It's perhaps time to do what IVHS became ITS. Is it time for connected vehicles to become something else in terms of terms?
Or become subsets of connected vehicles. Richard had a great slide there that showed all the different variations on the theme of connected vehicles, and they're all different. They all have different, I think, different deployment paths. They have different implementation schemes. They have different money-making potentials. And in the case of DSRC, it has a very unique place among all those different applications. And again, I agree with Richard's assessment on the timing for that, and as far as the aftermarket is concerned, I think that depends on whether there's anything else you can do with it. Maybe there would be an aftermarket option that would be financially viable if it did more than just the safety applications. If that's all that it does, then it might be a little bit difficult to justify the heartache and headache of trying to get something installed like that and have it be a safety application.
Yeah, that's a good point. Thank you. Right, I shall withdraw. Thank you. My question's been answered. Excellent. Gareth, you had some audience questions, thankfully.
Yes, we do. We've got quite a few. Whether we'll have time for all of them, I'm not sure. Just one point to cover in case anybody missed the beginning of the webcast. I will automatically send a copy of the slides to everyone that's registered for this, and I'll also send you a link to the recording of it as well. So that covers a couple of questions that have come in. I'll ask them in the order they came in. The first one is from Barry Kirk, and it's directed at Shelley, and it says, who will pay for the DSRC infrastructure? The provinces and cities here in Canada cannot afford it. Ditto US states and cities. Where will the money come from?
Yeah, so this is I think that's a really good question. And so I think there's two parts to my answer. Because first of all, when you look at the vehicle-to-vehicle applications, the way that's being developed is it doesn't need that pervasive infrastructure we talked about 1,000 years ago. That's not required anymore. So the models that are being considered now would basically be DSRC infrastructure free for V2V connections. The only thing you need to go back to infrastructure for is a security network and being able to certify and revoke certifications for the vehicles. That can be done across a lot of different wireless connectivity scenarios. It does not have to be DSRC. So if you're only looking at a V2V solution, you don't have a chicken and egg problem anymore. So that's one half of the answer. The other one is that then if you wish to choose to have a vehicle to infrastructure application such at a signalized intersection, then state and local governments can choose to do that. And the money would come from their regular, wherever they get their money today. There's no specific, unique, bucket of money somewhere to do that particular application. The idea is that it would create enough benefits for the agency in terms of safety or possibly mobility applications that it would be a cost-beneficial investment. And state and local governments make those trade-offs all the time today, but it just has to compete like anything else. But it would be on an optional basis for those particular locations and applications where you can justify the investment.
Okay, thank you.
Good answer, thanks, Shelley. Anybody else want to cover that?
I've got plenty more questions, Kevin, if we want to move on.
No, in that case, go through the questions.
Okay, we've got one from Sid Gokki, and it's a fairly short question. Can we get an abstract for the MirrorLink spec? The spec isn't free.
Yeah, the spec is not free, but you can download it from the MirrorLink.com site, so it's available. It's just that it is not free.
Okay, that's good. Thank you very much. The next question, again from Barry Kirk. The FCC decision is not to consider reallocating part of the 5.9 gigahertz. Instead, the FCC is considering sharing the band with Wi-Fi, an important distinction. I'm not sure whether that's a statement or a question, actually.
Well, ask another one then.
I'll move on to the next one. It comes from John Lees. Is anybody considering the connected car as a sensor for traffic management purposes?
So this is Shelley.
Yes.
Obviously, yes is the answer. But it's not. Again, it's the whole connected vehicle terminology. I would say that that's happening right now. That you have pro vehicles out there. You have several companies today that collect data from vehicles through wireless technology, and they sell the data. And a number of state DOTs, an increasing number, are beginning to purchase that data and use it for traffic management purposes. So that's a connected vehicle type application that we see today. It's just using pro data through cellular links.
Yeah, I think you're right, Shelley, and I think it would also be very valuable if we could get what I would call super probe data and get details from the vehicle about what the engine management system is doing and what the headlamps and headlights and things that would give us more detailed information about vehicle condition and perhaps driver behavior.
Mm-hmm. Yes, I agree.
I wonder if we're ready for that flood of data, though. I think it would be great to have, but do we have enough buckets to catch it all?
Yeah, there are a number of issues with that.
That's actually a good point, Bob, because that's the subject of the next webcast, big data. So again, nicely segued. Thank you very much. I will pay everyone for making these fantastic segues for me. But there's another question come in actually from Bill Oliver, who says, if vehicles are going to be able to follow each other more closely, saturation flow rates will increase substantially. Is it now time to quit adding lanes to roads to merely gain capacity? So that's another question about another strand of the connected vehicle idea. Richard, I can ask you that one.
Could you repeat that, Kevin? I'm having some noise on this.
Bill said, if vehicles are going to be able to follow each other more closely, saturation flow rates will increase substantially. So is it time to quit adding lanes to roads to merely gain capacity?
Okay. No, it's not time yet, but there will certainly be capacity gains from the combination of connectivity and automation. You know, what the car companies are putting on the market initially, since they're only systems, you are still subject to being stuck in a traffic jam. And that's where the connectivity comes in to improve traffic flows, both on a vehicle-to-vehicle perspective, as well as ideally with the traffic management center that's smart enough to manage very small sections of the roadway and provide very detailed speed suggestions or speed commands. You know, go from 68 miles an hour to 65 miles an hour, something like that, to really optimize the flow. So eventually we'll get there, but the needs for construction are going to stay for a while, I think.
It is time to begin.
Go ahead.
Oh, I would just say, Bob, it is time to be taking into account in long-range plans, whether it's 30-year demand models or 30-year alternatives analyses or general planning, the effect on both demand and capacity of some of these connected and automated systems.
Yeah, that's a very good point.
Benefits may well be realized in different types of roads differently. So, for example, might we see increased capacity on freeways before you see any increased capacity on urban arterials or even the off-ramps serving those freeways?
Well, I
And
have
the
a more
impact- I would
cynical
add-
view on this. Go ahead, Shelley.
No, I'm just going to add, I think those are good points in the long-range planning process. I think is a very relevant point. I would suggest also it's more than just the impacts on the roadway network, but you will eventually see impacts in vehicle design. I mean, the automated vehicle is a disruptive technology, and it's going to change a lot of things that we can only begin to glimpse. Today, I wouldn't stop programming projects, but I would be thinking about how to be flexible and how to consider projects that are 30 and 50 years out.
And my more cynical view as someone that lived in Southern California for a number of years, people are driving with reduced headways already, so automated vehicles should make it safer.
Are we ready for another question?
Yeah, let's go to
Yep.
another question.
Okay, the next one came in from Frank Provenzano. It may be similar to one we've had previously, but I'll ask it anyway. In the opinion of the panelists, how big of a blow to the DSRC initiative is the FCC's recent decision to share the 5.9 spectrum?
Well, I'll start. I don't think it's a blow
go ahead,
yet.
Sharon.
We don't know. Everything that I've seen so far is looking at potentially sharing that spectrum, and there was a lot of concern before I left the DOT that we didn't know enough about how the technology was going to work for the safety applications, and we're hesitant to offer to share just yet. I think everyone understands, though, that spectrum is so valuable that if, in fact, there was extra that we didn't need for the safety applications, then, yeah, it's going to need to be shared. It's more about can you do it and not jeopardize these safety-critical applications. So it's, I think it's a little bit too soon to tell. It's just it's unnerving that the issue has come up right now when the test is still underway and we don't have some of the answers that we would like to have.
Yeah, and I'll agree with that. Just to say it's a big question mark right now, more than anything else.
Okay, if that's it on that one, I'll move on to the next question. It comes from Paul Roberts, and it says, as a reporter covering IT security and privacy, one of the critical issues to me seems to be one of ownership. As vehicles start to act more like laptops or smartphones, who owns the data that they store? Do customers have the right, for example, to encrypt their car data to protect it from snooping or unauthorized access by a third party?
Good question.
Yeah, I can answer that. So you have a similar situation with smartphones today, right? So you have your location information, notifications and things like that, and generally there has been a model where consumers opt in or opt out with revealing certain information. The car manufacturers do that with their telematics services today as well. So I think we have a basis to move forward from. Obviously, the devil's in the details, but I think that we have precedent.
I think we also have a precedent for people trading off privacy for privileges and services. A few years ago, Washington Metro introduced a smart card with two ways to get one, to pay for fares. You could be anonymous or you could be registered, and if you were registered, they would track you because they wanted the trip pattern information. If you were registered, you were guaranteed balance recovery. If you lost the card or had it stolen, 98% of people chose to be registered and tracked. Maybe if we offer a deal and perhaps if it's opt-in, 98%.
I'd like to know who that 2% were that didn't, and
Uh-huh.
why.
They'll never let you know.
Well, those were the people interested.
I know.
Those are the people
that's-
interested in privacy rather than privacy. Yeah.
No, don't explain the difference now, but we've only got 5 minutes to go.
Okay.
Let's get another question before we end up
Okay.
Losing track. Gary, you got any more questions?
Yeah, no, we've got a lot more. We've got more than we're going to have time for, unfortunately. But I'll move on swiftly to the next one. It's come from Diane Robinson. It's how do you see transportation/trucking industry playing in this space in combination with passenger vehicles? Do you expect similar timing? Some aspects play a larger role in adoption consideration, for example, insurance monitoring, costs, vehicle maintenance, etc.
Well, I think if I was a truck driver, I'd be worried because I might not have a job too much down the line.
That's a good question. A huge amount of these discussions tend to focus on the passenger car, so I'm glad the truck question came up. There's one area being explored that's called cooperative adaptive cruise control. Regular adaptive cruise control, which is on the market now for cars and trucks, will be able to sense slower vehicles ahead of you and slow your speed down and match the speed of the vehicle ahead. Cooperative ACC has communications between the two vehicles, which allows you to shorten up the headway. And if you're a trucker, that translates directly to better aerodynamics, and that translates to fuel savings. So that is an area that's being explored now. There's a startup company in California called Peloton that's pursuing that. And Federal Highways just issued a solicitation for some research in that area. The chicken and egg issue is interesting because you can, if you're a big fleet, at least in the U.S. situation, some of these fleets are so big that they have their trucks going between hubs with high density, so it wouldn't be that hard to find a truck from your own company to couple up with. So I see a lot of potential for that.
But, you know, does it ferociously toot the horn for an extended period if someone jumps in front of you?
Only if it's you, Bob.
The Scottish version.
That's thought detector.
Okay, do we have
Gareth, go for it.
Yeah, do we have time for one more? Maybe this one comes in from Brian Burke. I have seen some application using the current GPS location technology. Is there any concern that this location protocol will be updated?
Yeah, I think we're relying on it being updated to get the accuracy we need, yeah.
I mean, the positioning question is important, particularly in V2V. You have to know which lane you're in and which lane the sending vehicle is in. I think in the U.S. side, the camp guys would say they've pretty well got the performance they need. I tend to hear the same from car to car in Europe, but I would say there's still questions, there's still a need for better performance. You know, I'd rather have a little better performance, so that's still being worked.
Cool. Now, Shelley mentioned the term earlier on that we assumed that all the audience understood, which was the SPAT message, which is signal, phase, and timing. So I guess the concern is that the vehicle might be ready for that information, but are the traffic signal engineers ready to deal with the vehicle information?
Well, I think that's a two-way street. I would,
Yeah.
you know, to my knowledge, other than the early research that was done in that area, the automotive industry hasn't created the application that would take the SPAT message, the signal, phase, and timing. So that one's a two-way street. And you know, if you put it out through a traffic signal system, then you know, there's a lot that has to go into that. If you think about it, and you know, my GM colleague is on the line as well. Just think about what it takes to read that information, create the algorithm, and figure out how to communicate it effectively to the driver in a safety critical situation. The other thing on that particular application that I think is relevant is that that application is most useful in the early days after DSRC technology comes out, and it decreases in importance the further you get with more vehicles with that are equipped with the technology. So it's kind of an early application, and if you can't get to it early, then it doesn't have nearly as much value as it does later.
Good point. I think it was the University of Southampton a few years ago who did some modeling research that indicated that once 20% of the fleet has perfect information, it doesn't get any better.
We have actually got time for one more question
Go.
from David Pickerel, who of course would have joined us on our first podcast or webcast had he not had a power cut. So is there some way we can let David speak?
I have tried to unmute him. If he's got a microphone, he should be able to speak now.
Are you there, David?
Can you hear me?
Yes.
Yes, we can.
Here,
Hey,
yeah.
David.
Oh, wonderful. Okay, yeah, I've got a new laptop since that. And I think the comment, I'll change it from a comment to a question because I want to get a point of view, not just pontificate. I do that enough in other instances, everyone knows. I think the issue that I see, and I want to get a reaction from the segments, is kind of IBM's viewpoint and my viewpoint in my current iteration is that it goes to the issue of talking about the fact that while a mobile device has a 15-month recycle, cars much longer, 10 years, 15 years, 20 years, people keep their vehicles for a long time. And I'd like to know what everyone thinks of the idea that IBM has is that whether it's in the cloud or whether it's somewhere else, the idea of as much that can be updated and changed in terms of software and hardware should be outside of the vehicle and allow the vehicle to be not so much a dummy terminal, but have the ability to have its software configured and updated over the air so that you don't have a huge expense or change out with having to swap vehicle components continual, because I think that's the big challenge a lot of the industry people see is replacing things like that.
Yeah, that's a good point. It's a difference in life cycle between the vehicle and the devices.
Yeah, that's an issue. I mean, essentially, software is easy to replace, respectively, when compared to hardware. But a lot of things we're talking about are going to require hardware. For example, the right sensors in the vehicle to track certain things and get that information out to the software layer. So, I agree that software, updatable software will solve some problems, but the nature of vehicle hardware and the vehicle life cycles, it's still going to be, some time before some of these things come to fruition.
So in the future, will the driver be regarded as the software? Hey, I wanted to come back on the question of who owns the data. There is a good analogy. If you look at corporate IT departments in big companies, there's usually a running battle between the person with the PC saying it's my PC, that's what it means, personal computer, and the IT guys saying, no, but it's our network, so there's only certain things you can do. So maybe there's an analogy between, is this a network that's to be managed, or is it an individual device with wheels on it?
Yep, and you see the same thing with, internet battles between the service providers and the network providers.
Yep.
There's a temptation to see a lot of these issues too in binary terms. Is it connected or not? Is it automated or not? Is the driver liable or not? Does the vehicle owner own the data or not? And as a legal matter, none of these are binary questions. They're gradations and there's segmentation of each of those. So the vehicle owner may well have a right to access some data. They may well have the technical capability to or not. At the same time, the manufacturer may well have access to or certain rights in the data that may come from contract and may or may not be restricted by law. So it gets very complex for any of these inquiries.
It's a good point.
Yeah, I live in
Just leave it on
Florida.
that point. Go on, Bob. One last point, Bob, because we're over.
One last comment. I live in Florida, and a lot of people during hurricanes choose not to evacuate because they think it's smart to stay at home and have a hurricane party. I wonder if at some point in the future, some person that didn't evacuate will get a call from their smart car saying, I've left you behind and can I have your credit card so I can buy some gasoline?
Good point on to leave that, Bob. Excellent. Now, one thing
Okay.
I wanted to mention was there's, I think, eight or nine questions we've not had time for. But when you do ask a question, attendees, they get logged. What we'll do is we'll send all the questions we didn't get time for to the panelists. If that's okay with them, maybe they can reply back to us in emails, and we can forward their replies back to you, the askers. Is that okay with the speakers? If you've got time for that,
Sure.
so over the next few days, that'd be great. Thank you. So those of you who didn't get the chance to have your question asked, you will get it answered, although clearly not publicly. So unfortunately, that's the end of the show. So thanks to Bryant Walker-Smith and to Richard Bishop and Alfred Tom and Shelley Rowe. Thank you for your time. It's not just the hour and a bit today. It's the research you've done and the sending us some slides and that kind of stuff and agreeing to take part. It's really, we're really grateful for that. Bob, thank you for your time and your jokes as ever.
Thank
Gareth?
you, panelists.
Well, no, yes, been a very good show. Now, the next one, as I mentioned, is about big data. That takes place on Thursday, the 11th of April, and the one after that, on the 2nd of May, is looking at machine vision. So we've got webcasts lined up until the 25th of July. So I will tell you more. Presumably you'll receive Thinking Highways magazine. There'll be adverts and all kinds of stuff in there. You'll get the email broadcast telling you who's actually going to be on the panel. Hopefully Dave Pickerel will be on the big data panel. He won't have a power cut this time. We've got some other people coming on. We have someone from some INRIX on the panel, someone from Trafax, and hopefully somebody from Cubic Transportation Systems who's going to confirm over the weekend. So I can give you more information next week about who's taking part in the big data one. But for now, that's it. So thanks so much for attending. Thanks for taking your time out of your morning or afternoon to listen to us. And thank you very much indeed, and hopefully you will hear us again in 2 weeks' time. If you celebrate Easter, have a good one. If not, have a good weekend. And thank you.